So the second concept we have here, a little less known one, probably going to be new to you, is the infinitesimal. And I'm going to pull up the graph that we used for infinity. And this was the one that was approaching 1. And again, I have that column there where we can see the output is approaching 1. And just by observation, I'm just going to look at the graph here and say, you know, this number 1 looks interesting, like the function is getting closer to it. I'm just from observation. And so I'm going to take the difference from this number 1 and the function and make this new column. And so the difference from 1, if we look at this difference, it's getting smaller and smaller, and its difference is approaching 0. This difference is actually getting forever smaller. So if I wanted to continue with more inputs, we would see this get forever and ever smaller and smaller. And this is another key concept, like infinity, something that continues forever. And infinitesimal is something that also continues forever, but it's something that gets smaller and smaller. And eventually, we would say then that this difference is approaching 0. So just like infinity, we have something that continues forever. And the infinitesimal in this case is something that gets smaller. But unlike infinity, something else that's different is that it is bounded by 0. And you may be thinking, well, what about negative numbers here? And I am talking about a difference in absolute value, the distance from the origin. And when talking about distance, that's always a positive number. That's what the absolute value gives us. And you can never get closer to something than 0 distance from it. And that's what we're talking about here with the infinitesimal, that this difference here is getting forever and ever smaller, but it's bounded by 0. So while infinity is not a number, which means in many cases it's inappropriate to just throw the symbol in an equation, however, sometimes it still is useful to do that to express an idea. So while not mathematically rigorous, an infinitesimal is like 1 over infinity. And again, I think this is something that we see with numbers. If we just take the number 1 and forever divide by 10, then we would notice the pattern with these numbers. That as we can divide by 10 forever, that this number will get smaller and smaller and smaller. It gets forever smaller. Now I do want to stress again that infinity and an infinitesimal, these are not numbers. They don't express a quantity. So let's say I have 5 pens in a box. Well, that number 5 is expressing a quantity, the number of objects that I'm seeing in this box. I'm seeing 5 of them. If I would say, however, there are infinitely many pens in that box, I'm no longer giving you some finite quantity. I'm not saying there's 100 there. I'm not saying there's 1 billion there. I'm saying that the number of pens that are there, if you want to count them forever, you will find there is no bound to how many pens there are. Infinity is not a finite quantity like a number. Now, if I would say that in my box there are an infinitesimal amount of pens, now I'm really saying something strange, physically at least, because I would be saying that I have a pen that's getting forever smaller. And of course, that's not something we see in the universe, but that's what it would mean. So it is difficult to connect physical analogies to infinity and an infinitesimal. These are, I would argue, properties that we see from the numbers, and we've given these properties these names. As a final thought on the infinitesimal, It is true that there is some controversy with it. There are mathematicians that definitely don't like infinitesimals, and there are various reasons for that. And my position here is not to convince you what is good here. Hopefully, as you go through calculus, you'll form your own opinions. But I do think the infinitesimal is a very good teaching tool to help express these ideas. And calculus actually began with infinitesimals, but because of the distaste it had with some people, they eventually came upon the limit. The limit does replace ultimately the infinitesimal, and we will get to the exact definition of the limit in section 2.3.